right, so for record purposes, today's topic is regulation and homeostasis. Let's get to the first slide. All right, so we have a little beach setting here today. So let's talk about, obviously, regulation and homeostasis. Let's get to, but before you start to read that definition of what homeostasis is, let me break it down into simple terms. Let me ask you one question. What is a healthy body temperature? We should all know this because we've been through COVID, and almost anywhere we went, whether it's to the supermarket or to the pharmacy, we had to take our temperature. What is considered to be a healthy temperature, right? Roughly, you can round it off to the nearest whole number if you wish. Sarah, correct? Come guys, it's an easy question. What's a healthy body temperature, right? Marika, correct. Nicole, also correct. Caitlin, correct. Right, Josiah, not totally correct, but one of your numbers is correct. So let's just round it off to roughly 37 degrees Celsius. This is considered to be healthy. All right. So how does your body keep its temperature at 37 degrees Celsius? Even if you go to a very cold country, let's say you go to Canada during winter. So this is inside your body, right? So inside your body, that's supposed to be you there, right? Your body keeps its supposed to keep itself at 37 degrees Celsius. But once again, let's say we went to Canada in the heart of winter, when outside could be like -5 degrees Celsius. It's really, really, really cold. Now, even though outside is really, really cold, the outside will try to drop your temperature. It will try to freeze you, but your body will still find a way to keep itself at 37 degrees Celsius. Even if you go to the desert, let's say you go to the desert and it's 45 degrees Celsius outside, the desert will try to raise your body temperature, but your body will say, no, I don't care what the outside temperature is. I am going to try to maintain a healthy temperature of 37 degrees Celsius. So in other words, when it comes to your body temperature is going to try to fight the outside temperature and not succumb to the outside temperature. It has a duty to maintain at 37 degrees Celsius. So that's one type of homeostasis. Homeostasis is when your body is fighting the outside conditions to maintain something constant inside. But it's not only about body temperature. Let's talk about the amount of water in your body. Believe it or not, but everyone should know this, too little bit of water in your body could be dangerous. That's why you need to what? Drink water. But did you all know that too much water in your body is a problem? So let me put this on a cell level. Let's say you have this here is supposed to be one of the cells in your body. So this dot here is going to be your nucleus. Anybody can tell me what's the kind of jelly-like stuff or the water-like stuff that everything swims around in your cell? Like you have the mitochondria, you have ribosomes, but all of these things, the mitochondria, the nucleus, everything that's inside the cell kind of floats around in this liquid. What's the name of that liquid? And that starts with the letter C. And a lot of people are sending the answers across. It's called your cytoplasm. Now, the cytoplasm has a lot of what in it? Water. It's a kind of watery, jelly-like substance. Now, if your cells have too little bit of water, you could think it will look something like this. It will kind of dry up and it won't have plenty water in it. So everything will be kind of squished together in in the cell, right? It comes like if somebody drains out all of your blood from you. You'll kind of shrivel up, right? So this is what happens when there's too little bit of water in your body. But it can also be dangerous to have too much water in your body. Think of a balloon. If you put too much water in a balloon, it could stretch the balloon, and of course, eventually the balloon will pop, right? The same thing with cells. If you have too much water in the cytoplasm, it will cause what? The cell to kind of like swell, and that is going to damage the outer layer of the cell. Yeah, they actually have a name for it, and I'm asking you to memorize it, but it's called osmotic cell damage, right? Or osmotic damage, where too much water can damage the cell, just like how too little bit of water can damage the cell or be unhealthy. So your body has a way of maintaining a certain amount of water in the body. Not too much, not too little bit. It always has to be the right amount. So that is what homeostasis is about. Homeostasis is about maintaining something constant in the body so that there's not too much of it or too little bit of it. So that is what this definition is trying to say. All these fancy words are basically trying to say that. And there are many different types of homeostasis in the body. We're only going to be discussing 3 for the syllabus. One called thermal regulation. Whenever you hear the word thermal, it deals with heat. So thermal regulation is how your body is going to maintain a constant, healthy temperature. Osmoregulation has to deal with the amount of water in the body. So your body doesn't have too much water or too little bit of water in it. And number 3 should be, I'm very familiar, blood glucose regulation. This has to do with the amount of sugar in your body. Remember, some people suffer with high sugar. Glucose is the sugar we're talking about. And some people suffer with low sugar. It's very important that your body has a certain amount of glucose in it, a certain amount of sugar, because too much can be damaging and too little bit can also be dangerous. We're going to be discussing all 3 in a few minutes. I want you to take down everything on the screen. Let me know when you are finished, and we will move on. All right, so we're going to start off with thermoregulation. As I mentioned, when you hear the word thermal, it deals with heat, the heat in your body, which is at 37 degrees Celsius, the healthy temperature. So let's see what these monsters are saying here. So, well, if they ask you for a definition of what thermoregulation is, right? Thermoregulation is how an organism maintains a constant internal temperature despite external conditions. External conditions are like the temperature outside, like the winter conditions, or if you're in a desert. It doesn't matter what the outside temperature is. For human beings, the internal temperature must be 37 degrees Celsius, right? Different organisms require different internal temperatures. So that 37 only applies to human beings at the moment. So if they ask you to define thermoregulation, this is exactly what I want you to write in the exam for your 2 marks. You will get a nice little 2 marks for that in the exam, right? So, and over here is humans need to keep, I mentioned this already, humans need to keep their internal temperature at 37 degrees Celsius because, and here's the reason, right? Let's say you ask someone, what is the correct temperature for a human being to have? And you all answered that already, 37 degrees Celsius. Why? Why do we need to keep 37 degrees Celsius? Why that specific number? Well, remember last term, we bounced up something called enzymes. Anybody remember what enzymes are? Let's say I ask you this question in the exam for 1 mark. What is an enzyme? Send your answer on the chat. Let's see how much you can remember from last term. What is an enzyme? Enzymes. So first of all, there are many different types of enzymes in your body. Usually when a teacher explains enzymes in integrated science or HSB, they're talking about digestive enzymes. For example, if you have proteins in your body, right? This is one type of enzymes that I'm talking about. Let's say you eat something full of protein. Let's get an example. Let me say you eat a piece of chicken. Chicken meat has a lot of proteins in it. So your body has to break down the proteins into smaller parts. And these smaller parts are called amino acids. Now, your body just can't magically break down proteins into amino acids. There are these special proteins. I'm drawing it like this. It doesn't look like this in real life. I'm drawing it like Pac-Man, right? There are these special proteins in your body, right? Called enzymes. And these special proteins called enzymes will attack the proteins and break it down into smaller parts called amino acids. There are also special proteins that will attack carbohydrates and break it down into glucose. You see, these special proteins, they need a special temperature to live in. I'm just letting you know this. You see, anytime the temperature in your body crosses 40 degrees, the enzymes begin to die off. Enzymes cannot survive temperatures over 40 degrees. In fact, they work best at 37 degrees Celsius. Believe me, if your body loses all its enzymes, that means it's unable to break down any foods into smaller pieces. And if your body cannot break down those foods into smaller pieces, right? Your body cannot get its nutrition. And your body will slowly begin to what? Die off. So that's the reason for it. Enzymes in your body need a certain temperature to work at. And of course, if it's not at that temperature, you begin to die. Now, I want to point out, digestive enzymes are just one type of enzymes in your body. You have enzymes all over your body. In fact, inside your eyes, there are enzymes that need to be at 37 degrees to live. Inside your respiratory system, the system that provides energy to your body, so your brain could work, so your heart could work, also needs what? Enzymes. Okay? So I want you to take down everything on the screen here, right? So clearing up a few things here. Right. So before we move on, right? There's a little octopus here. He's going to be like the star of our story. He says, can you please explain how our body does this when the place is hot and the place is cold? Because up to now, I have not explained how your body actually maintains a constant temperature. Like if the place is too hot, how does your body cool down its body back to 37? And if it's too cold, how does it raise back the temperature to 37 degrees Celsius? And that's going to be on the next slide. How your body does this balancing act, this magical act. All right, so let's see what this skit is about here. So a lot of people, without me asking, they gave me the answer of how your body cools itself long, right? So let's say that you're in the desert, right? Oh, look at the octopus. He's on this very, very sunny beach. The sun clearly looks like it's really, really hot. And let's say that the temperature of the sun and the wind blowing is roughly about, let's call it 42 degrees outside here. So as we all know, whenever the place is hot, we sweat. Sweat is really, really important because when sweat goes on your body, the next step is for it to evaporate. Whenever evaporation happens, evaporation means the liquid is turning into a gas. So the liquid sweat is turning into water vapor. I'm not going to go into the science behind it because I'm not going to ask you it in the exam. All you need to know is when sweat evaporates, it causes a cooling effect. I can prove that to you. You ever sweat plenty and then you went in front of a fan, and when the fan blows on you, it feels cool? How much of y'all have noticed that? You just feel extra cool. Like if you don't sweat and just go in front of a fan, it feels nice. But if you have sweat on your skin and you go in front of the fan, you feel extra cool. How much of you have ever noticed that in real life? Or whenever you have wet skin, let me say instead of sweat, you just throw a whole set of water over your body. Not sweat, just normal water. And you go in front of a fan. Won't you start to feel cold after a while? You know why that is happening? Because the water is evaporating. The wind from the fan is making the water or sweat evaporate faster. And the more evaporation you have, the cooler your body feels. So that's one mechanism that your body does to reduce the temperature. Now, most people could figure that out. Like that's general knowledge. That sweat, evaporation of sweat cools the body. But I have a harder question for you guys. Let's say the place gets really, really cold, right? So let's do a little skit here. The sun comes down here, right? The place gets extra hot. You can see it gets brighter, right? When the place warms up, your sweat glands release more sweat. We all know this. I now mentioned that, right? Right, so just give me 1 second here. Let's see what's going on with this. So you can see that the octopus is starting to sweat here. That's not tears. That's supposed to be sweat, right? Right. But let's talk about, oh, sorry, I needed to take down that note. The next part of the explanation is, and I'm going to ask everyone this, and you can think about it. When the place gets really, really, really cold, how does your body warm up itself? Think about that. Now, that's a harder question because when the place is cold, you're not going to sweat, right? So how does your body raise its temperature? Take down the note, think about the question that's been put forward. And of course, if you could send it on the chat, it will be appreciated. When the place gets cold, let's see what's going on with my little skit here. I think the sun is supposed to disappear. And then the place gets cold, right? So it begins to snow on this beach, right? That's little snowflakes and whatnot there. Do you all realize that when the place is cold, you begin to shiver, you begin to shake, and there is a reason for that, right? Here's the explanation. You all remember the general formula for respiration? When your body takes glucose and mixes it with oxygen in your mitochondria, that's where respiration takes place, your body, right? Well, most textbooks just say three things that your body will do what? Produce carbon dioxide, water, this is water here, H2O, and energy. But I remember on the first day of class last term, I told you that respiration also produces what? Heat. So when your body begins to shiver, like when the place gets cold, your brain gets notified. Hey, the body is too cold. The temperature is dropping. Let's increase respiration. because respiration produces what? Heat. So your brain sends signals to your body to start shivering. Remember, when you're shivering, your muscles start shivering is really the contraction and relaxation of your muscles. So your muscles begin to contract really, 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 really fast. And it looks like it's vibrating, better known as shivering. To shiver takes energy. And there's only one way your body, well, one of the ways your body can produce energy is through respiration. But there's a byproduct, heat. So the more your body shivers, the more respiration is required. Hence, the more heat is required. And of course, that heat generated from the shivering is going to raise back up the body temperature to 37 degrees Celsius. Whenever you are shivering, never try to stop shivering. You know, some people have pride, right? They'll be like, oh, I'm shivering. They want nobody to see. Do not stop shivering. Let your body shiver. Because if you mentally fight the shivering, your body will not be able to warm up back properly and you could die. So shivering is actually a good thing, right? You should let your body shiver. All right, so take down everything on the screen here, right? Right, and the octopus well finally gets the idea. Oh, that heat generated helps warms us up. Right, so take down everything on the screen here. Let me know when you are finished. All right, so we have a little game here to play, right? To take the little boredom off here. So I know some of you all probably played this game for those who do physics with me, right? But I changed up everything. The outcomes are different. So how the game works is a real simple game, right? Let me play one with you guys. You have to do three things, right? You have to choose any number between 1 and 100. 1 and 100 is included. So let me help you play. I already can't remember the answer. So I'm going to choose the number 37. Then choose any letter of the alphabet. I'm going to choose X. You can choose anything you want, obviously. And then choose one of the tokens. Either the potion, the eyeball, the bat, or the hat. I'm going to choose the potion. Let me know your selection on that side. Senator, choose a number, then a letter, and then one of the tokens. And the aim is, you're trying to defeat a witch, right? But you don't want any of your items to show up. So once one of your items shows up, you lose, right? So just for fun, send it on the chat here. Let's see what you guys come up with. It's a game based on luck, right? So a lot of people send their, let's go to the next screen now. Now remember my one, right? Just to prove that I'm not cheating. 37X. Sorry. I chose 37X and the potion. So what's going to happen now? The witch is going to pull some items out of each cauldron. Now, if any of your items appear, you lose. So let's see the first one. Anybody's out of the game? Was anybody unlucky enough to choose 44? If you got kicked out by first rounds, that means you're real unlucky because you had between 1 and 100 to choose. Did anybody choose P by chance? If you chose P, you're out of the game. And the last one, the eyeball. So if you chose 44, P or the eyeball, any one of them, or even worse, if you choose 2 out of them, did anybody survive? I survived because I chose 37, X on the potion. Right, the first round's easy. I just did this one because the chances of you losing the first rounds is very, very, very slim. All right, a lot of people survived this one. If you did not, well, Gabriel, I don't think you made it because you chose the eyeball. All right, so you all know how to play the game now. So when you reach the next rounds, it should be easier. All right, so let's talk about another type of homeostasis. What about osmoregulation? Well, osmoregulation is when your body tries to maintain a certain amount of water. Remember, I explained too much water is bad. Too little bit of water is also bad, right? It's like Goldilocks, like when she went to by the bear's house. When it was too hot, it wasn't good. When it was too cold, it wasn't good. There's always an in-between amount. That's the right amount. Right, so the monsters are telling us they can't help us with this question. We need to swim down further down the beach and ask Mr. Crabono. So let's go meet Mr. Crabono down in the beach here. That's Mr. Crabono there. Let's see what information he has for us. We ask him to explain, the octopus ask him to explain what is osmoregulation. So Mr. Crabono tells him, hey, drink this glass of water. All right. So the octopus drinks the water. Right. So notice what happened to the octopus. He said he was not thirsty in the first place, right? But he still drank the water. In real life, if you're not thirsty at all and you just decide to drink water, will you go to the washroom more or less? Just from experience. You're not thirsty, you're not feeling for water, but you still went and drink water. Of course, you will go to the washroom more to urinate because your body didn't need the water. So you drink the water. Now your body needs to get rid of the water. How does your body know to do this? I find it's amazing that you drink too much water, you go to the washroom more, but you never probably ask yourself, hey, how did my body figure that out? That I had too much water and now I'm feeling to go to the washroom to get rid of it. So let's explain the science behind that. I don't think Mr. Crabano is a nice crab. But he's probably very crabby. All right. So let's see what's the science behind this here. You see, inside the body, there's a special hormone, right? Called ADH hormone. ADH stands for something called antidiuretic hormone. We're just going to call it ADH. And ADH is a special hormone. And in case you can't remember what a hormone is, right? There are many hormones in the body, but hormones are special chemicals in the body that tells your body to do something. And ADH, this hormone is produced naturally in the area of the brain. There's an area in front of your brain to the front of your forehead that actually produces this hormone, right? And the name of that area of the brain, we haven't done the brain as yet, right? We will do that later down, right? Is the hypothalamus, right? It's a handful to pronounce, right? Some people just call it the hippopotamus, but obviously they do that as a joke, right? It is then released by the pituitary gland at the base of the brain. So this first note is just telling you which part of your body is responsible for creating ADH. Now let's talk about what ADH does. Let's have a little diagram here. This little blob here is going to represent Mr. ADH, that chemical. And here's what he says. Hi, I'm ADH. I love water and I will hold on to it. So let's analyze what that means. Since ADH likes water, let's pretend that inside this octopus now, he has a lot of ADH. Let's say his brain just produces a lot of ADH. Will he go to the washroom plenty, or will he go to the washroom a little bit to urinate? What do you guys think? He's loaded with ADH now. His brain is just mass producing ADH. Once again, will he go to the washroom a lot or a little bit? Think about it and send the answer on the chat. Right? It's important to get involved in the questions. Remember, ADH loves water and will hold on to it. So if his body is loaded with ADH, the ADH is going to hold on to that water. He's not going to let go of that water. So all the water is going to stay inside the body, which means if he's holding on to that water, he's not going to go to the washroom to get rid of the water. If you like something, are you going to let it go? No. So when your body has a lot of ADH in it, you will not go to the washroom plenty. Are we all clear on that? For those who got it wrong, you think you understand it? I think you all just naturally assume that ADH will make you go to the washroom to urinate, right? So let me know in the chat if you all understand that, right? Great. ADH loves water. He holds on to it. You're not going to go to the washroom. Great. So let me see if I have any other notes here to take down here. Right? Oh, look, and now he said, if there's plenty of me, water will stay in your body. I guess that's a simpler way of saying it. If there's very little of me now, if your brain does not what? Produce plenty ADH, well, your body not going to hold on to the water, which means all the water is going to be passed through your system and you're going to urinate and give it to the washroom, right? So I want everyone to take down everything here. And then, yes, I want you to draw the little blob here, call him Mr. ADH and put it like little comic panels and everything now, right? I know some of y'all don't like drawing, but if you draw a little crab here, the crab doesn't have to look really, really great or anything like that. But, you know, draw something, draw something. And let me know when you are finished with this slide. All right, so let's see what's going on with Mr. Crabono here. So let's analyze what's going on in your body now, right? So apparently, we're gonna zoom in into this to this octopus body here. So we're gonna zoom in here, and you'll notice that in his body, I'm gonna point to some parts, and you're going to tell me what the names of these parts are. Some of them should be pretty easy to label. Just give me a few seconds here. I'm going to do the first one, obviously. The first one is the brain, right? Who can tell me what this kidney shape is here? What is that? Oh, I think I gave away the, oh Lord. I gave away the answer. So I said kidney, my mistake. I was supposed to say bean. All right. So this is your kidneys. And who can tell me what this is? Your bladder, correct. I'm not going to go into the rest of it, right? So that's your bladder. Let me explain, that's the basics. We're going to do this in detail later on, right? Your kidneys does a lot of filtering. And in one case, all the water that your body does not need will be sent to where? Your bladder. And from here, well, from your bladder, you go to what? The washroom. Now, before we move forward, let's see how much you can remember. If the place is really, really, really hot, right? Will the amount of ADH in your body be high or low? Now, I'm not going to give away the answers. Eventually, I'm going to reveal the answers. Let's say the place is really, really hot. Your brain, the front of your brain, is supposed to produce ADH. Remember, the front of your brain here, there's a little gland that produces ADH. Will your brain produce a lot of ADH on a hot day? I just want to see if you all get the concept. So some people saying yes, and some people saying no. Right. So I think I still need to go into the explanation here. Remember, ADH loves water. And when I say loves water, right, it doesn't make you drink water. When I say loves water, it makes your body hold on to water. So if the place is hot, shouldn't your body hold on to as much water as possible? Because on a hot day, you want inside your body to have plenty water. So I think on a hot day, your body will have plenty ADH. So your body will hold on to that water. So that means if your body is holding on to the water, your kidneys will only send a little bit of water to your bladder. So you will not go to the washroom plenty. However, if the place is cold and rainy, right? Your body will only produce a little bit. I'm sorry to use this, a little bit of ADH. So if your body on a cold day, rainy day, produces a little bit of ADH, then your body is not going to hold on to that water, which means the kidneys is going to send plenty water to your bladder, and you will go to the washroom plenty. Now, I'm not asking you to take down anything here, but you're going to see me give you notes on this just now. But it's a good idea to hear it first from me or try to reason it out first. So let's analyze what's going on in the body here, right? Your brain senses too much water in your body. Remember, the octopus was forced to drink a lot of water a few slides ago, right? So your brain senses too much water in your body. So it produces what? Less ADH. You know why? Because he has too much water in his body now. So his body does not want to hold on to that water because he wasn't thirsty in the first place. The ADH from your brain is sent to your kidneys. So your brain will send the ADH to your kidneys. And of course, if there's only a little bit of ADH being sent to your kidneys, the water will what? Come out of your body because your body is not holding on to the water, right? And I'd say, but I'll put it in note form here, right? Great. I need for you all to take down this here. And yes, I want you to draw the octopus with its kidneys and its bladder and everything. And take down the notes exactly like this. Does this note make sense? I know I said that up quite a few times, but just making sure. Does this note make sense? Alexandria, good. See what happens. Right. So the sun comes out now. If you saw in the right-hand upper corner there, the sun comes up. So the crab says, let's see if you can guess what happens when the place is really hot. Now, obviously, the opposite is going to happen, right? He's going to begin to sweat, right? Remember, when you begin to sweat, you're going to lose water out of your body. So your body is going to what? Need water to replenish the water that you lost, okay? So your brain, in this case here, senses too little water in your body. So it produces more ADH. And why does it produce more ADH? So your body can what? Hold on to the water because it doesn't want to lose any more water because it's losing so much water by sweating. I don't think you should lose any more water by going to the washroom, right? So it would send that ADH to the kidneys. It would send, anybody sees the mistake in my note there? Anybody wants to tell me what the note, who can tell me what the mistake? I made one mistake in one of the notes. Is the mistake in the first rectangle, the middle, or the one underneath? See this spot the error. It wasn't intentional. I really genuinely made a mistake, but I was reading it. Right. It's the middle, right? Remember, your brain senses too much water and produces more ADH. So plenty ADH is sent to your kidneys. So your kidneys know now to hold on to the water. Don't let water leave the body. We need water inside that body. So it's supposed to be more here. In the kidneys, more ADH means more water will be reabsorbed from the urine back into the blood. So your body is going to hold the water. Any water that's in your urine is going to try to take it back into your body because the ADH wants that water. Right? So take down this note here with the correction. And yes, I want you to draw the diagram again, right? So take a 5 minutes, take a 5 minutes. Oh, well, I think you all deserve a small break there. You did a lot of writing. So the game has changed a little bit. The only change is this. You have to choose a number between 1 and 75. The ranges are going to get smaller to make the game harder. Right, so you all know how to play. Choose a number between 1 and 75. 1 and 75 could also be chosen, right? 1 or 75 or anything in between. Any letter of the alphabet and one token. Let's see what you guys come up with. I'm going to play along because I can't remember this one. I'm going to choose 5M, and I'm feeling for the bat here. 5M bat. Test your luck, guys. Test your luck. All right, so let's see if you guys win. All right, so let me put my choice here to see if I win here. 5M, and I chose the bat. I'm not cheating, I'm not cheating. First one, 7, 11, or 53. If any of you all picked any of those numbers, you are out of the game, right? The witch has won in that case. For the second cauldron, M, oh, I'm out. M or Y. So I'm dead, right? So I'm out of the game. Third cauldron, the hat. Anybody was able to survive all 3 cauldrons? Elizabeth, you won. Alexandria won. Adam, you won. Kamaya. Abida, I feel your pain. Right. All right, guys. So, oh, somebody chose the M and the hat. Lord. Sorry, guys, for those who lost. All right, so let's move on. All right, so this here, the reason I included this slide, because I saw this question actually come in the past papers. So the octopus asks, so what exactly should I write in the exam if they ask me to explain the importance of osmoregulation? And let's see what Mr. Crabano has to say here, right? Osmoregulation is the process that controls the amount of water in body fluids, example, blood, right? It prevents osmotic damage of the cells. So this is what I want you to write in the exam, right? So osmoregulation at the end of the day is how your body controls the amount of water in your body. But you can't say it like that in the exam. You have to say it in very fancy language for 2 marks, right? So take down that, right? And of course, we will move on in about half a minute. All right, so apparently a whale has washed up on the shore. And of course, the crab is telling us, well, we need to go talk to the whale about blood glucose levels. All right, so here's the whale that washed up on the shore. Not too sure how he ended up on a hill, but whatever. All right, so here's our protagonist, the octopus. Can you explain how the body controls glucose levels? All right, anybody wants to take a guess of which part of your body controls the amount of glucose? It's not really the brain. Like there's a huge structure at the center of your body that plays a vital role in controlling the amount of glucose in your body. I'll give you a hint. It starts with the letter L. It's not the only thing involved, but it's a major part that's involved. Right. Well, there's only one part of the body I can think that starts with L, other than legs, right? It's the liver. Oh, it's the lungs. Well, sorry, liver. But liver is the answer. So when it comes to controlling the amount of sugar in your body, we're going to see the liver involved. So let's see what's going on here. I guess we will need the diagram of a liver to help us out, right? So let's see what's going on here. So the dying whale has decided that he will sacrifice his liver for this explanation. So let's see what's going on here. Goes here, takes out the liver. Ah, there we have our liver. All right. So that is how the liver looks in real life. Now, I want to point out something. The liver has a lot of functions. If you look online, the liver has about 400 functions in the body. One of them just happens to be the control of glucose, right? All right, so now we have a diagram. Let's explain the basics of sugar control. You see this green glob here? His name is glucose, right? And of course, glucose is found in the blood and cells and used for respiration. We know this from since last term. We need glucose for respiration, and you can find glucose in your blood. But the key is you can't have too much glucose in your blood. There's a certain amount. So let's see what he says next. Oh, it looks like it has plenty of his friends here. So looks like there's plenty glucose, right? When your body has too much glucose, me and my friends are grouped together. So this is exactly what your body does, right? What your body is supposed to do, keyword, supposed to do. When there's too much glucose in your blood or in your body, or where not supposed to be, what your body will do, it will group all the glucose together. And it will store it in the liver. And it will be renamed glycogen. So glycogen is basically stored glucose. Well, whenever you're storing glucose inside your liver, you can't store it as pure glucose. Your body will change it to a compound called glycogen, right? So anyway, take down this note here. I want you to take down this note and we're going to build it up slowly. So take down that small note there. Right. Now, there's this part of the body. You all would have met it last term when we were doing the digestive system. There's this part of the body called the pancreas. It's close to your stomach. It's almost in the same area of your stomach. And the pancreas does quite a few things, right? But he's responsible, well, partially responsible for converting glucose to glycogen or vice versa. Vice versa means the other way around. So it's two things involved here, the pancreas and the liver. The pancreas does something to tell the body, hey, there's too much glucose in the body right now. Convert it to glycogen. And when we convert it to glycogen, store it in the liver for the time being. So it's out of the bloodstream. So it's safely secured in the liver. Now, vice versa means now sometimes in your body you have low sugar, like you don't have enough glucose in your body or in your bloodstream. Well, then the opposite will happen. Your body will take the glycogen that is stored in the liver and release it back into your bloodstream, right? So it's a kind of to and fro process, right? So glucose could be converted to glycogen, and whenever it feels like, it could convert back the glycogen to what? Glucose. Take down this note. I know it's a little bit confusing still, but I have some really good diagrams after to clear up this uncertainty here. Right, so let me know when you finish with both notes. Let me see if I have anything else. Nope, we don't have nothing else there. Right. And does this make sense? Glycogen belongs inside the liver. I think we mentioned that just now. And glucose belongs outside the liver. You see, glucose belongs in your blood, where it could be delivered to all the cells. Glycogen is the stored form of glucose when it's not in use. It's like a fridge. Let me say you have some pizza and you don't want to eat your pizza right now. You will take the pizza and store it in your fridge. The fridge comes like your liver. And only when you want to eat the pizza again, you will take it back out of the fridge. Right? So take down this purple note, and then I believe we can move on to the next slide. Right? So glycogen belongs inside your liver, and glucose belongs outside the liver. All right, so that's what your pancreas looks like there, that weird shaped thing there, right? Hi, I'm the pancreas, and I do a lot of things, including making two hormones, right? The pancreas makes two major hormones. One of them, I'm pretty sure you heard about it. The first one is insulin. And the second type of hormone it makes is glucagon. That's the other G word I was telling you about. So insulin and glucagon are two types of hormones. Remember, hormones tell the body to do something. They are special chemicals that order the body to do something. Insulin, when your body produces insulin, it will tell your body to convert the glucose into what? Glycogen. And remember where the glycogen will be stored? In the liver. If your body produces glucagon, it will do the opposite. Glucagon reverses what insulin does. It will take the glycogen, which is in the liver, and convert it back into glucose. And of course, glucose doesn't belong in the liver. When the glycogen is converted into glucose, it will send it back out into the blood. Right? So let's take a guess here, right? If you have high sugar, let me say you're diagnosed with high sugar. Which one should your body produce? Insulin or glycagon? Take a guess. If you are diagnosed with high sugar, which one should your body try to produce? It should be insulin, right? Because the insulin will take the glucose, remember glucose is the sugar, and it will convert it to glycogen and store it in the liver. So that means it will get the glucose out of your blood. It's taking the glucose out of your blood, the high sugar, and converting it into glycogen and storing it in the liver. So it's not in the bloodstream anymore. For those who got it wrong, you think you understand it? And the opposite will happen now. If you have low sugar, if you are diagnosed with low sugar, meaning that you don't have enough sugar in your bloodstream, your body will make glucagon. It will take the glycogen from your liver and convert it back into glucose. And it will send that glucose into your bloodstream so it could raise the sugar level back up to its normal level. All right? Don't worry, I'm going to be saying that quite a few times again today because I know from experience it's easy to mix up what insulin does and what glucagon does. Not only what it does, when it is actually needed. And I know these 3G words are going to tie you up for a little while. Glucagon, glycogen, and glucose. Let me know when you're finished with this little, what do you call this thing here? This little bubble here, comic bubble. All right. So let me explain what this diagram is about, right? You will see the pancreas over here to the right. Remember, the pancreas produces two types of hormones. You see it here, insulin or glucagon, right? It produces those two. Over here, we have the liver, and the red is supposed to represent the blood in your body. So right now, from just looking at the diagram, do you think this person has high sugar or low sugar based on the amount of sugar that you're seeing in the blood? Does this person have high sugar or low sugar? Right, so I purposely put a whole set of green jelly blobs that represent the sugar. So right now, if they test this person's blood, right, they will say, hey, you're suffering from what? High sugar. Having too much sugar in your blood is very dangerous. So what's going to happen now? A message is sent to the pancreas. Hey, Mr. Pancreas, there's too much sugar in the person's blood. The pancreas says, okay, which one does the pancreas produce? Will the pancreas now start to produce insulin or glucagon? Which one will he begin to produce? Take a guess. Josiah, correct. Rosita, correct. It's going to produce insulin. So look at the animation here, right? The glucose in blood is high. Okay. Pancreas is notified of this problem, right? And then you notice what it did? The pancreas produced insulin and sent it to the liver. So, right. So you all know what the insulin will do when it reaches the liver. It will take, look how much of the glucose disappeared, right? Because what the liver is trying to do now, the liver is going to absorb the glucose from, or the excess glucose from the blood and convert it to what? It's going to group it into the liver and store it as glycogen. All right? So, because, and look at it now, the amount of sugar in the blood has been reduced. That's the normal level, okay? So, but when you store the glucose in the liver, right, it's called glycogen. You don't get to call it glucose anymore, right? Everyone okay with that there? Right. I'm not asking to take down anything here. I just want to know if you understand the concept, if you understand this concept. All right, so let's go back a little bit more. All right, so right in this second situation, the whale has low blood sugar, sorry. So what's going to happen is that the pancreas is going to be notified of this. So the pancreas is notified that there's a dangerous situation here. There's a little bit amount of sugar in the blood, and the whale is feeling lightheaded, and he wants to faint, and he's feeling weak. Which one will the pancreas produce now? Will he produce insulin or glucagon? Which one will be produced to combat low blood sugar? It's glucagon, right? So look at what's going to happen. Huh? The pancreas produces the glucagon and sends it to the liver. All right, so the liver gets the message now. He just received glucagon. Guess what the glucagon is going to do? It's going to take the glycogen, which is stored in the liver, and convert it back to glucose. So the glycogen disappears from the liver and it's released back into the blood, but it's released as glucose because glucose belongs outside the liver in the blood and glycogen belongs inside the liver. So look at it now. The whale has normal blood sugar levels. It was low, but because of the glucagon, it returned to normal. All right. So once again, I'm not asking you to take down any notes. I just want to make sure that you understand the animation. We're going to have a lot of past paper questions on this, where I'm just going to talk about it over and over and over. Right. Right, so the blood glucose is now normal. All right. So believe it or not, right? This is the end of homeostasis. How do you find this topic was? Easy, medium, or hard?